So for our rigid motions, we've done transformations, we've done translations and reflections, right?
Yes.
Okay, today we are going to do what are called rotations. So a rotation is also a rigid motion. It is a transformation. That rotates an image around a given point. Okay, and then the example that we've been doing with our triangle, let's say it's right here, and I want you to rotate it around that point. So we would,
Around what point?
around this point.
Okay.
Let's say I want to do it 90. So we would rotate it, here, let's do, it would look like
so
this.
So it'd be upside down? No.
It would look like this. Mine goes
This is
off
gonna
my
confuse
picture.
me. But there's gonna be
Yeah.
a way to know how to do this, right? There's gonna be a method.
Okay. Something like that. So basically it rotates like this. Okay. The point that we rotate our image around is called the center of rotation. So the center of rotation is the point given, which the figure rotates around. So in our picture, I'm going to try and do a better job. Would look like this. Your center of rotation would be right here. So the point that you're rotating around. Okay.
Okay.
But then we also have the angle of rotation. And the angle of rotation is the number of degrees the figure rotates. Okay, so in our example last time, that's your angle of rotation. So however many degrees we rotated it. Okay. For our purposes, we are only going to be rotating in increments of 90 degrees. So we will rotate shapes 90 degrees. We will rotate them 180 degrees. We will rotate them 270 degrees. And I guess we could rotate them 360 degrees, but that's just back where you started, right? So
I hope we get a question.
for ease, we're only going to rotate 90, 180, and 270, and mostly around the origin. But sometimes we will be rotating around different points, and I will show you how to do that in just a second, okay? So here's what we are going to do. Let's do the notes first, and then we'll do our rotations, okay? So 8.3, rotations. Here's like the official, very mathy definition. A rotation of x degrees about a point Q is a transformation with the following properties. The image of Q is itself, okay? So when I take Q and I take the image, the point center of rotation stays the same. For all other points, QV prime is equal to QV, and the measure of angle QVQ prime is equal to x. So basically what it's saying is that the distance from the center of rotation to any point on the figure is the same distance as from the center of rotation to the image. Okay, so it's equally distant, equally the same, and the angle of rotation stays the same. Okay? It is a rigid motion, so here's the big thing you need to know. Rotations preserve distance. What else? We've written it like 3 times now.
Come on, I got this.
Angle measure.
That's what I was thinking. I'm not even joking, but I didn't want to say it.
And what I mean when I say angle measure, that means that in the triangle, all of the angles in the triangle are the same as the angles in the image of the new triangle. So in this triangle, that's the example, angle V has the same measure as angle V prime. So the angle sizes don't change. That's what it means. And distance has to do with the segments. So VU has the same length as V prime U prime. So that's what it means, that the shape stays the exact same size and the angles don't change size either. Rotations map each point of the pre-image to how many corresponding points?
1.
1 and only 1.
I knew that.
Okay? So when we say in math 1 and only 1, that means like never are there any special cases, never is it 0. It's always 1 to 1. Okay? It's a very specific math term. There is a function notation for rotations. Reflections was a capital R, so rotations is a lowercase r. And then our subscript is always the angle of rotation and where the center of rotation is. So in this case, we're going to use Q as the example. Sometimes it might be a point. So the angle of rotation and the center of rotation of your shape, which in this case is triangle UVW. Okay? So similar to what we've been doing. So here's what we're actually going to do. Before we get into the notes part, we're going to rotate some of the shapes. So let's do, but we're going to start doing it with patty paper, and we're going to figure out what the rule is, and we'll come up with the rules together. So everybody gets one of these. 3, 4, 5, 6. This is called patty paper because it's the paper that goes in between hamburger patties. And you buy it, I'm not joking, that's really why it's called that. This is what, you know when you buy frozen hamburger patties?
Yeah.
This is that paper.
Oh my gosh.
I know. You have to buy it at the grocery store. Basically. Okay, so everybody gets one.
Can I fold it?
I don't have a ton, so please do not rip it. Okay, here's how we're going to do it. This is super useful for doing stuff like rotation. So we are actually going to rotate segment AB around the origin, and we're going to rotate it 4 times to get the points. So I know the instructions here say that we're just going to do it once, but we're actually going to do it multiple times. So here's how we do this. You are going to, let me use purple. Take your patty paper and put it on top of the graph, and you should be able to see the pre-image underneath, and you're going to trace it. So you're going to trace segment AB onto your patty paper.
I think that's funny.
And I would label the endpoints too. We have A and B. Oh, I forgot to tell you guys one very important thing. So after you're done tracing, duh. Oh my God. And Rebecca. Okay.
Ooh, are we just gonna like...
Yeah. But I forgot to tell you one thing about our rotations. At the very, very top, go back. Unless otherwise noted, all rotations are counterclockwise.
That is important.
Yeah, that's very important. Okay. Counterclockwise, so if you think about a clock where the 12 o'clock is right here, so let's say this is 12. Clockwise would be to the going this way, correct? So counterclockwise is going the other way. Okay, so that's counterclockwise if we go to the right. Okay.
We should just buy a new clock for this place.
I have a math clock that I used to hang up every single year, and for some reason I didn't put it up this year.
Why not?
I know. I'm going to find it. Okay, so let's now look at number 1. And this is going to be kind of cool. So here's how you do this. You put it on top of the segment, and then we need to take our pencil because you need to indicate your point of rotation. On the problem, it says we're going to rotate 90 degrees, and then it has an O. What do you think the O stands for?
From point 0.
0, 0, which is called the origin. So that's what the O means, origin of the segment, okay? So we're going to put this over the segment. We're going to put our pencil on the origin. And 90 degrees just means one turn to the right, I guess. So you're going to go like this.
Whoa.
There's a 90 degrees. Okay, so here's how we're going to do this. We need to figure out what those coordinates are. I'm going to use different colors. You just have to make sure that you're labeling them correctly. If you want to use different colors, you can. Or highlighters sometimes are useful. But at least for sure label them correctly. So B is going to end up right here.
What's it at?
We're going to look that up. That's yeah, that was counterclockwise. I turned it counterclockwise. Unless otherwise noted, all rotations are counterclockwise. Yeah.
This is kind of hard to do.
And we do that because this is quadrant 1, and then to find quadrant 2, we go which direction? Counterclockwise. So that's why we rotate counterclockwise. So that's B prime. Let me do this again. So if B prime is there, A prime should be here.
It's at like -3, -2, right? What? Yeah, -3, -2.
-2, -2, right?
I got -3.
-3, -2. Oh, you're right. -3, -2. A prime. Okay. And then you take your straight edge. Because it was at what? -2, 3. So -3, -2. And we draw the segment.
How do you do this without
How do you do this without the patty paper? So here's what we're going to do. I want to write out the coordinates and then the rotation coordinates, and we'll see if you guys can figure out the pattern. Okay? So let's do A and B first. What were the coordinates of A? -2, 3. And what were the coordinates of B?
positive 6?
6, 6? Did you guys get 6, 6? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6, 6. Okay. You guys ready? Let's figure out A prime. What did A prime come out to? -3. What?
2.
-2.
6. -6, 6.
And what did B come out to? -6. +6. Okay. Let's see if we can figure out the pattern. What happened to the A coordinate? It swapped, and what happened to the new x coordinate? It turned negative. Did the new y coordinate change at all? No, it stayed negative and negative. What about b? It's hard to tell because they were both 6's, but what do you think happened?
The x became negative.
They swapped, and then the new x became negative. Do you think that will follow through if we rotated it 90 degrees again?
Yeah.
Okay, so let's make a prediction. We are predicting that a double prime, if we flip-flop these again, -3 is going to be the new y, and what's going to be the new x? +2, because we did the opposite, right? What do you think will happen to b double prime?
It will be
-6 and -6. So if we flip-flop these, this -6 goes here, this goes here, and we take the opposite. Let's test it to see if it works. So here's how we do it. You put it back on the original. I think it's easier to do back on the original. And this time we're going to rotate not 90 degrees, but 180. So we rotate 90, and it matches up with where we were, and then we rotate 90 again. And it should match up here. So let's put the point there. So here's going to be our A double prime. And our B is going to be right there. Here. B double prime. And then double check the coordinates to see if we were right. So we said A double prime was going to be at 2, -3. So 1, 2, 1, 2, 3. And we said B was going to be at -6, -6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Good job. So if we rotated 270 degrees, what do you think is going to happen?
okay.
So here's what I want you to do. Find A and B triple prime for me without using your patty paper, using the pattern that we just noticed.
So it will be 3, 3, 2.
And then use your patty paper to confirm it. So 270 is 3 rotations. And then we're going to do number 2 without the patty paper. Just using the
Really?
Okay, guys, what did you get for the coordinates for A triple prime?
3, 2.
+3, 2. And what did you get for B triple prime?
6, -6.
6, -6. And when you graphed it using the patty paper, did that confirm it? Okay, so there's 1, 2, and 3. So it should be 3, 2, which it is.
Oh, Oh yeah, it looks like a
So that's A triple prime, and B was 6, negative 6, so 6, negative 6. Right here. Make sure you labeled all the points.
dang, this is
Okay, so we can make some generalizations about rotating, right? Okay, so go back up to the how to rotate about the origin box, and I actually have it for you. So if our original coordinates were x, y, okay, so we're going to use the original coordinates x comma y as our originals, and the rest are all going to follow. When we rotated 90 degrees, we flip-flopped where x and y were, right? So y is in the new x place, and y became negative. Now, if it was already negative, what happened to it? It became positive. So this actually means the opposite, okay? If we rotated it again, so 180 degrees, these flip-flopped again, and we ended up with two opposites, right? But everything was in the correct spot. If we did it one more time, now the y was what it originally was, but the x was still opposite. And if we did it one more time, everything turns out to be what it started as. Okay? So this box is going to come in super handy for you until you get these memorized. All you really have to memorize is what happens with one rotation. And then you can get all the other rotations from there.
on 360. You put 3,000.
Oh my gosh, I did. It is just 360.
I'm gonna
Thank
fill
you.
in the zero.
Okay, so what we are going to do is we're going to rotate, do number 2, we're going to rotate segment XY 180 degrees without the patty paper. So here's how I do it. I always start with writing my X and my Y coordinates. So my X coordinate is at negative 1, 2, 3, 4, so negative 4.
What am I doing?
1, 2, 3, 4, 5, 6. Positive 6. Okay? So always start with writing the X and the Y coordinate. And then I ran out of room, so I'm just going to do the Y right here. The Y coordinate is at 1, 2, 3, 4, 5, 6, negative 2.
So x would be
And then using the rule, I write out what X prime, Y prime are going to be. So let's look at our box. Do the X and the Y switch places at all?
no.
No, but they both have negatives attached, so that means we change the sign of everything, right? So for X prime, instead of negative 4, it's going to be
Positive.
positive 4, and instead of positive 6, it's going to be
Negative.
negative 6.
This is cool.
And then let's do Y prime.
Negative 6.
So instead of positive 6, it's going to be negative 6, and instead of negative 2, positive 2. So let's graph it. 4, negative 6. So there's X prime, and Y prime would be negative 6, positive 2.
Hey, it's like parallel lines.
They are parallel lines. Do you think that will always happen?
Ms. Dawson,
Yes.
I thought you'd switch the X and the Y.
Not for, it's a 180 degree rotation. So 180 degrees. They've already switched once with the 90, and then they switch again for the 180. So our rule was that they end up in the same spot. That kind of matches up with our previous one, right? In the previous one, the 180, weren't they parallel? Mm-hmm. Okay. Any other questions? This box with the rule is going to be your best friend. So what I'm going to have you guys do for 350, 35. For about, I'm going to give you 10 minutes. Oh my gosh, I made the exact same mistake on number 8. Number 8, it should be 270, not 200, 2,700. What you guys are going to do is you are going to rotate shapes for me, 1 through 8. Okay? So you are going to do 1 through 8.
3 through 8 or 1 through 8?
I'm sorry, 3 through 8. We've already done 1 and 2.
I meant like 3 through 8 or 3 through...
And then we're going to do 9 and 10, where we rotate not about the origin. So I'm going to show you how to do that. But to start, I want you to practice 3 through 8. 3 and 4 are 90 degrees. 5 and 6 are 180. 7 and 8 are 270. Okay?